So we're working on Unit 910, Constant Rate of Change, and we're going to cover some material from boxes D and boxes E. In box D, we're talking about dependent and independent variables, and in box E, we're going to look at what finite differences are and how we calculate them. So first off, dependent and independent variables. In any relationship that we have between two variables, we're going to have a dependent variable and an independent variable. And the relationship between the two of them is here in the second line. The dependent variable always depends on the independent variable. So one thing always depends on the other. Now, why is it important to be able to recognize the dependent and the independent variable? Well, if we're plotting these, the dependent variable is always going to go on our y-axis. And it's always going to be the second thing in the table. The independent variable is always going to get plotted on our x-axis. And if you're making a table of values, it's always going to come first in the table. So let's take a look at a couple of situations here and see if we can figure out what variables are involved and which one depends on the other one, or which one is the dependent variable and which one is the independent variable. So our first situation here is we're looking at the height of a tree over time. So our variables here are going to be height and time. That's what we're looking for a relationship between. Now, to figure out which is independent and which is dependent, what we do is we sort of ask ourselves which one depends on the other. Does the height of the tree depend on time, or does time depend on the height of the tree? Well, I think it makes more sense to say that height depends on time. Because the tree is going to grow over time, so the longer we leave it, the taller it's going to grow. So its height depends on the time. That means if height depends on time, height must be dependent. And if height is dependent, time has to be independent. Dependent. Okay? And when time is one of your variables, 99 times out of 100, time is going to be the independent variable. Okay? So let's look at situation 2. Number of computers sold compared to the selling price. We're looking at number of computers is our one variable. Our other variable is going to be the price. And we ask ourselves, does the number of computers that we sell depend on the price, or does the price depend on the number of computers that we sell? Well, I think it makes more sense to say that the number sold is going to depend on the price. So that makes the number of computers the dependent variable, and the price the independent variable. Number 3 here, the population of Canada over the past 30 years. What are two variables? We've got population, and we could say this is over time, or the number of years. So, is the population going to depend on the number of years that have passed, or is the number of years going to depend on the population? Well, I think it makes more sense to say that the population depends on the number of years. So population is going to be dependent, and number of years is going to be independent. Last one here. Changes in your heart rate with the number of stairs that you have climbed. Well, our variables are heart rate and number of stairs. Now, is your heart rate going to depend on the number of stairs, or does the number of stairs that you've climbed depend on your heart rate? I think it makes more sense to say that the heart rate depends on the number of stairs that you've climbed. So the heart rate is going to be the dependent variable, and number of stairs is going to be independent. What this means is that if we were making a table of values of heart rate and number of stairs, because number of stairs is independent, it would be the first thing in our table. So we would have number of stairs, okay, and then we would have heart rate over here. Okay. And if we were doing a graph, the independent variable always goes on the x-axis, so we would have number of stairs down here, and we would have heart rate up here. And that's what our graph would look like. Okay? So if you're going from a table to a graph, the first thing in the table always goes down on your x-axis or your horizontal axis. The next thing we need to look at is, or are, finite differences here. Now, what are finite differences? Finite differences are changes in the dependent variable, or the y variable of a table, when the independent variable, or the x variable, increases by the same amount each time. Okay? And it's easiest to see if we take a look at an example. Okay? Here's how we would calculate finite differences if we've got a table of values. First thing we look at is, in our independent variable, so our x, is that going up by the same amount each time? Well, let's see, it goes from 0 to 1, so it goes up by 1, then it goes up by 1 again, then it goes up by 1 again, then it goes up by 1 again. So yes, our independent variable is going up by the same amount each time. So to calculate our finite differences, we're going to start with the last y value, and we're going to subtract the y value above it. So we go to the bottom of our table, our last y value is 16, and we're going to subtract the y value above it. 16 minus 8 equals 8. So that's our first finite difference, or I guess our last finite difference. And then we're going to go to the y value above it, 8, and we're going to subtract the one above it. 8 minus 4 gives us 4. And we keep working our way up the table until we filled in all of these lines. 4 minus 2 equals 2. 2 minus 1 gives us 1. What good are finite differences? Well, this gives us another way of figuring out if our relationship is linear or nonlinear. If the first differences are not all the same, the relationship is going to be nonlinear. So we've got 1, 2, 4, 8. This is a nonlinear relationship. Let's take a look at the next example here. Again, we've got a table. Okay, x and y. We check to make sure, yep, our x's go up by the same amount each time. So we can go ahead and we can calculate our finite differences. Start down at the bottom of the table with our last number, subtract the one above it. 15 minus 12 is 3, and then we work our way up. 12 minus 9 is 3, 9 minus 6 is 3, 6 minus 3 is 3. So our finite differences are 3, 3, 3, and 3. In this case, all of our finite differences are exactly the same, so the relationship here is linear. So this gives us a way of figuring out if a relationship is linear or nonlinear without having to do the plot. We can calculate the finite differences and check to see if they're all the same.